So we are going to talk about this, maybe this thing in today's class, okay, and then we'll finally reach to A star search. Search, we have seen that there are states, there is a notion of actions and costs, successor function, and there is a start state and a goal state. There are nodes and we have plans that have costs. And then we talked about search algorithm that systematically builds a search tree, chooses an ordering of the fringe, and optimal is the one that finds the least cost path. Okay. Pancake problem. Now, what is going on in this particular problem? So, what happens? You put this whatever you call it, and then you can flip the pancakes that are above it. So, in this case, if you put this thing here, flip it, what happens? This comes at this position, this goes at this position. Basically, whatever the state of the affairs is above this, that will get flipped. How can I get this one? By flipping it where? Here. Alright, what about this last one? Flipping this whole thing. Okay. Now tell me, how would you assign cost to this? If I am saying this is one state, you go from this state to this state, how will you assign costs? Okay. So the number of pancakes flipped. This is how you have chosen to do it. Okay. So what is the cost of going from here to here? What is the cost of going from here to here? 2, right? Because these 2 were flipped. In this case, 3, and in this case, 4. Okay. Let's do more of it. So as they always do this. Now, why is this problem important? So this problem is important because it was studied by Bill Gates back in 1978 with Chris Papadimitriou. So people know him, but he is a big shot in computer science at University of California at Berkeley. So the problem has many more other applications too. How many of you know about the DNA of mouse or mouse and human beings? How much are they similar? Huh? Sorry? Right? Right. So आप कोई भी चीज देख लो, सारे एक्सपेरिमेंट्स ह्यूमन ड्रग्स के माउस पे होते हैं, बिकॉज डीएनए ऑफ माउस एंड ह्यूमन इज more than 90% same. But where are the changes? You know, in this whole long what do you call it? DNA strand. ये चंक हटाया, इसको रिवर्स करके कहीं और पे लगा दिया, right? Only these kind of things are there. So this problem finds an application in DNA sequencing too. कि which chunk you flip, put it somewhere else, and so on. And of course, it's a computer science problem, so for its own sake it is important. It's an optimization problem. Now I don't get this graph. Can you help me figure out what is this? What is this 4? So if I flip this, I go from this state to this state. Why bidirectional? I mean, why in both these directions? Because it does not matter. If I am coming from here to here, if I flip 4, cost is 4. If I go from here to here, cost is 4. So you see, this is symmetric. Going from one state to its neighboring state cost me same. So going and coming back, both will have same cost. Okay. Is that fine? So why is this 3? I flip this and I get this one. Fine? Chalo. So एक बार ये देख लो. This algorithm is repeating, I don't know, abhi it is coming for 3rd or 4th time. And we know it. What is it? Function tree search. There is a problem that is given to you. Strategy. What is strategy for us? Think over. returns a solution or failure. Initialize the search tree using the initial state. We know we have to always start from the initial state, and in a loop what do? If there are no candidates for expansion, then return failure. What is this? If there are no candidates for expansion, we have done all this. So basically if I don't have anything in fringe, this is what it means. If there are no candidates for expansion के candidates कहाँ पे थे? Fringe में. So if my fringe is empty, nothing to do. Now, if this is not the case, choose a leaf node for expansion according to strategy. What is that? So what is this leaf node? Remember, fringe was being built such that whatever leaf nodes are there at that moment, they are there in the fringe. Okay. So basically you are talking about fringe. So choose a node from fringe for expansion according to strategy. What is this strategy now? This is same as this one. How are you exploring it? Can be BFS, DFS, UCS and others that we have seen. So if the node contains a goal state, then you have to return the corresponding solution, else expand the node and add the resulting nodes to the search tree. What is this last line doing? Adding nodes to the fringe. We have done this a number of times before, but we will still see this particular pseudocode again and again. So we start from here. This is in my fringe. Now my fringe becomes what? Fringe is just the set of leaf nodes. So in this case now this goes out of fringe. This is fringe. So my fringe is this. Okay. By the way, give me the cost. 2 because first 2 got flipped. 4 because all 4. What is the cost here, by the way? I don't know. So 3. Okay. So this is 3 here. All right. This is my fringe now. That guy got expanded. What is my fringe? This whole thing. Okay. Now don't bother about what comes next. Now you expanded this whole thing becomes the fringe and you keep on doing this. Now what is special about this? This is my goal state. This is what we were looking for. Now any strategy that we have done until now resembles this? Not yet, right? So because if you were doing UCS, you would do 2, 3 and then 4 maybe. So we are just trying to illustrate the fringe here. So path to reach the goal, flip 4, flip 3 and total cost is 7. We have seen this slide before. How do you implement fringe? Right? We have seen that all this thing. This slide we have seen before. Now uninformed search. Okay. What was informed search, by the way? Remember? DFS says do this. So we'll talk about this. Uniform cost search. We are calling it uninformed because remember this thing, uninformed, ये जो ऊपर लिखा हुआ है ना, this uninformed, it is in this context. What do I get from this figure? You start from here, you expand. What does this circle mean? You expand uniformly in all directions based on the cost, irrespective of, you don't have absolutely any idea in which direction should I go for goal. So uninformed means I have absolutely no information which direction I should go to reach to goal state. If it were informed, give me, what should I do? I directly go from here to here. If I were completely informed, I will directly go from start to goal. Right now I am not at all informed. Informed means I have no idea where is my goal state. So I will explore all the nodes that have cost 1, then all the nodes that have cost 2. So these concentric circles are basically representing my cost. Okay, and this is the minimal cost. Will UCS always take me to optimal? Is UCS optimal? Is UCS complete? UCS is complete under which circumstances? So I try to trick this with this. Okay? UCS is complete only if no negative costs. Right? Am I right? Okay. So strategies to expand the lowest path cost. We have seen this. Good is it is complete and optimal. The bad, explores in every direction, no information about the goal location. So when you would be independently looking at these slides, uninformed का यहाँ पे क्या मतलब है? UCS has absolutely no idea where is my goal, in which direction should I go. Okay? So this is what it is doing. Cost less than 1, all explode first, then less than or equal to 2, then less than or equal to 3. They don't have to be at the same level, right? They would be at the same level, in which case UCS will be same as BFS. In that case they both are same, right? All right. So let me redo this. This is UCS and empty means there are no mazes here. Okay. So this is UCS, expanding uniformly in all the directions and it reaches goal. Same as BFS right now. In this case, BFS will do the same. Now, so demo contours UCS empty. Let us see this one. Yeah. Tell me what is happening here. So you start from here, you expand uniformly in all the directions. So let's do this again. The farther you are, later you will reach. Okay? Is this fine? Should be. Okay? Chalo. Now, do I have one more? I don't. Okay. Now we talk about informed search. So we know what is uninformed. I have absolutely no idea about which direction should I go to locate my goal. Search heuristics. So a heuristic, now we are talking about a different topic. Uninformed को अपन ने एक बार close कर दिया है. Okay. Now we are talking about a different topic. Search heuristics. So a heuristic is a function that estimates how close a state is to a goal. So we are trying to inform our UCS now that it is better to go in this direction to find the goal rather than expanding uniformly in all the directions. So heuristic is a function that estimates how close a state is to a goal, designed for particular search problem. A heuristic is for a particular search problem. Exam mein if I ask you for pancake, heuristic will be different. If I ask you for that Romanian map, heuristic will be different. If I ask you for this Pac-Man problem, heuristic will be different. So given a problem, you will talk about a heuristic. Okay. Right. So help me figure out what are we talking about in this case now. So examples are Manhattan distance, Euclidean distance for pathing. What happens in this case? Where do I start from? Here. My only goal state is I go and eat this pellet. Okay? How should I do this? Remember, this is the same figure जो अभी पिछले वाले डेमो में था, right? So what will UCS do? Expand in all directions uniformly. What does that mean? Okay, go and explore basically every possible state, because this seems to be the farthest from this point. In terms of path length, this seems to be the farthest. Okay, so most likely वो last में आएगा. It will even explore maybe things like this here, which are absolutely irrelevant. Okay. So what is Manhattan distance? Everybody knows. So if this, so Manhattan distance you move only in, so either straight or in perpendicular directions, right? So you can only move along the axis, in only in those directions. There are no direct paths. So if you see here, let's say this horizontal distance is 10 and vertical is 5. So 10 plus 5, 15 is my Manhattan distance. Okay. Euclidean distance will be point joining, I mean line joining this point and this point. So this is what Euclidean distance is. So these are heuristics in this case. Okay, and we'll make sense of it. So a function that estimates how close a state is to a goal. How are these two estimating this? ये जो अपना गोल है यहाँ पे, अटेंडेंस लेना शुरू कर देना यार टाइम पे ही ना. हाँ, अच्छा एक बात बताओ. No matter what I do, can I reach to this pellet in a distance less than 15? No matter what I do, can I reach to this pellet in a distance less than 15? If there were no mazes, can I reach to this pellet in less than 15? Strictly less than 15 can I reach, or I can reach less than or equal to 15? Less than or equal to 15, strictly less than 15 I still can't reach. Okay, but if you have put mazes here, have you made the problem more difficult or easier? If I remove all these mazes, problem becomes easier or more difficult? Easier. Okay, so so this is what it is. You are trying to find a bound on how far are you from goal state. In this case, if you use Manhattan distance, that distance is 15. In case of Euclidean distance, 11.2. By the way Pac-Man works, will it take this path ever? No, right? But we will still use such kind of heuristics. What is heuristic? वापिस आ जाओ एक बार. You are trying to estimate how close a state is to a goal. So in this case now, what was heuristic in our previous case? Heuristic was, if you are using Manhattan distance, heuristic value was 15. अभी लिख लो. It may not make sense right now. If you are using Manhattan distance, h of x is 15. If you are using Euclidean distance, h of x is 11.2. And a note that you may want to write alongside, that if you are using this distance, there is no way you can reach to the goal state in a time whatever, distance less than 15. Okay. So similarly, now you give me this. So let me help you. No. So okay, there is a hint here. Hint के answer is here. So look, what is this? Straight line distance to Bucharest. What is our start state? What is our goal state? And our goal is to find shortest path from Arad to Bucharest. Now this is the hx. ये सब तो, all these costs are कौन सी? The one that is given to you in map. Who has given you this? You, in this endeavor to solve this problem, you have come up with this hx. It is not the part of problem statement given to you. what was given to you is this map, these costs, and a problem statement that this is your start state, this is your goal state. This is the only thing given to you. You worked hard to figure out what is the straight line distance to Bucharest. यहाँ पे कितने nodes आ जाएंगे भाई? All these nodes in this graph, because you are talking about straight line distance to Bucharest from all these. So straight line distance to Bucharest from Bucharest is 0. From Arad it is 366, and so on for everything. Can I reach from Arad to Bucharest in a distance less than this straight line distance? कहाँ पे है भाई? This one? I start from Arad. Can I reach to Bucharest starting from Arad in a distance less than 366? Yes or no? Why not? You can't have a distance shorter than the straight line distance. Now, ये जो roads बनी होंगी, right? They will at most be, I mean, at best they will be equal to that straight line distance. But usually roads are not straight line distances. Okay? So, ये जो distance है, whichever it is, will it be greater than or equal to the straight line distance? Yes. How many of you agree, disagree? How many of you want me to repeat some things? I see some blank faces. Ah. See, सबसे ज़्यादा प्रॉब्लम जो लास्ट में अपन पिछले 5-7 मिनट में कर रहे हैं, सबसे ज़्यादा प्रॉब्लम ये फेस होती है कि why are we doing this? Okay? So there are two parts to it. What was the first part? There was thing called uninformed search. We said your algorithm has no idea in which direction should I expand. So that part is closed. I have no idea. Now second part starts, which talks about these heuristics, where I'm trying to figure out कि कोई तरीका है क्या I start moving in direction of goal rather than uniformly expanding in every direction. Okay? Make sense? So now अब ये गोल रख के अपन अब we are just trying to understand these two things. Pacman वाले केस में क्या था? You can't reach to goal state in a distance lesser than 15 if Manhattan, 11.2 if Euclidean. In this case, you can't reach from Arad to Bucharest in a cost that is less than 366. Everybody agrees to this? इसमें समझने को कुछ नहीं. हाँ. In this case, अपने Pacman वाले केस में, there are all kind of distances that you can define. The point is, in case of Pacman, even Euclidean does not make sense, right? But yes, there can be more distances. एक second. So we have not talked about any solution yet, right? Now in this case, can you give me the heuristic function? पिछले दो केसेस में heuristic की क्या प्रॉपर्टी थी? It was better than the best you could do in this problem. By in case of our map problem, what was the property of straight line distances? That is the best distance. Your original problem can't give me a solution better than this one. What about Pacman problem? जो 15 था आपने, your original problem, in the original problem I can't go from here to here in a distance less than 15 if you are talking about Manhattan distance. ज़्यादा क्यों लग जाएगा? Because you have mazes. So your problem is more difficult than what I am comparing it to. Big questions here. I see many blank faces. So then you have to do this one for me. what will be the heuristic function here? And let me help you. So this is the heuristic. So yes, they have it here. So this is the complete slide. So this is these are the heuristic values, and this is how you are choosing the heuristic. The number of largest pancake that is still out of place. पिछली दो प्रॉब्लम्स में क्या थी प्रॉपर्टी? The heuristic was better than, I mean the original solution cannot be better than heuristic. एक लाइन अपन बोल सकते हैं कि my original solution cannot be better than heuristic. So in this case, अच्छा एक बात बताओ, why is this 0? So the number of largest pancake that is still out of place, nobody is out of place, so this is 0. Why is this 3? Number 4 is on place, and after that we have 3, so third is out of place. Why 4 here? This seemed in some sense fine, but this guy is out of place. So why 4 4, I mean why 4 4 4 fine, but why this heuristic works for me? In this context जो अपन ने बताया, क्या बोला कि your original solution cannot be better than my heuristic. अच्छा ये बात बताओ, I want you to give me the total cost to go from here to here. करो एक बार. 7? How come 7? कैसे करेंगे? So flip this guy and then flip 3 again, right? एक काम करो, choose any of these and try to do it in a cost less than what is written here. कर पाओगे क्या? Question is, start with any of these states. Try to do it in a cost. So try to go from any of these states to this state in a cost lesser than what is written on these nodes. करो एक बार. So एकदम ये 2 वाले से शुरू करो. Can you do it in a cost less than 2? भाई 2 flips तो आपको इसमें चाहिए ही. All right. So अब 3 वाले को करके बताओ एक बार. आप इसको 3 से कम कॉस्ट में इस स्टेट पे ला सकते हो. I don't care. मेरे को तो ये बताओ, can you do it in things better than this? But in a way, heuristic will give me a cost, right? And my original problem was also about costs. Anybody can do from here to here in a cost less than 4? अच्छा बताओ कि जितने भी 4 लिखे हुए हैं उसमें 4 मिनिमम कॉस्ट क्यों है? Why will it always take at least 4? अच्छा, okay, let me put it. So give me a state which will cost me exactly 4 to reach to goal state. Give me a state which will cost me 4 to reach to this state. Iska opposite, right? You flip just once, cost 4 because you have flipped 4 pancakes, so that gives me 4. That is the best case. None of this belongs to my best case, so it's going to take at least 4. Can I talk about other reasoning? If I'm supposed to flip things, right, this 4 must be on top, then only I will flip and I'll come to down. So in all these cases, I am worse than that best case, which is, this is the only state from which I can reach to this state in just 4 cost. Everything else is going to take more than this. Everybody agrees? Yes or no? Right? So what are these numbers? Again, I want you to make a statement same in terms of जो अपन ने पहले पैकमैन वाले में बोला, फिर रोमानियन मैप में बोला, और अब अपन इसमें बोलने वाले. You start from a start state. You can't reach to the goal state in a cost lesser than what this gives you. Does this represent a lower bound on the number of costs that you will incur to go from here to there? Yes or no? Let me ask this question. Original question. Is it more difficult than this one? इसमें क्या कर रहे हो? The number of largest pancake that is still out of place. Original वाले में क्या कर रहे थे? The number of pancakes flipped, right? In this, so ये इसमें मैच होते हैं दोनों. Rest में this is simpler than original problem. So this represents heuristic for me in this case of. I don't see convincing faces. No. No. See, Manhattan वाले केस में what is the statement we made? If you remove all the mazes and everything, you still can't do it in less than 15. So if you are going to put mazes there, then you are only going to make things more complicated. In case of Romanian problem, we said I am giving you straight lines. No matter which path you give me from the original map, you can't give me a path that is less than 366. In this case, no matter which position you are giving me, if I were to go from here to here, it will cost me at least 4. Is that true? This is all we are looking for. All these costs, do they represent a lower bound? That is, it does not matter which state you are starting from. You can't do it in less than 4. You can do it in 4 in only one case. In which case you can do it in 3? This one too. So there are specific states from where you can go from here to here in 4, 3 and 2. Everything else is going to take more than this. There is absolutely no state जहां से आप you can go from here to here in a cost less than 4, 3, 2, basically 4. Right? There are very special states. So in this case, cost is 2. You can't do it in lesser than 2. There is only one statement I am trying to make. You can't go from here to here in a cost less than 4. Does this make sense? Okay. All right. So now we talk about greedy search. This is our heuristic function. Same slides as before. Greedy search. Expand the node that seems closest. Alright. Then Arad's neighbors are Sibiu, Timisoara, Zerind. Arad was in my, let's start fringe से start करते हैं. So Arad is in my fringe right now. Okay. Arad को अपन ने expand किया तो I'll get Timisoara, Sibiu and Zerind, and right now I'm exploring Sibiu. Arad, Fagaras, Oradia and RV. Okay. What do I do? Why Fagaras here and why Sibiu there? यार इसमें 4 GB रैम है. Okay, so we start from here. Why Sibiu? What is your strategy right now? So it is not BFS, it is not DFS, it is not UCS, it is not anything else. Your fringe is right now being expanded. So your strategy is basically this, that seems closest. So 253 seems closest. We expand that. Now why Fagaras? 176 is lesser than all of this. Now Bucharest distance is 0. इसको बाद में. Is this fine? अब तो आ चुका है. देखो यहां पे कुछ गलत हुआ क्या? So it is giving me path Arad से Sibiu, cost is 140, then Fagaras, so 140 plus 99 plus 211. So this one gives me 310 plus 140, that gives me 450. Can you give me a better path? 140 plus 80, that gives me 220. 220 plus 198. So 418. Right? So 418 is lesser than 450. What went wrong here? देखो आज की क्लास से आप ये मान के चलो मिड टर्म में क्वेश्चन आ रहा है. राइट? यस. So what was your strategy? Expand that node which seems, ये अच्छा वर्ड है, which seems closest, but it is not guaranteeing कि that is actually the closest. ये कौन सी strategy है अपनी? Greedy. Okay? All right. So greedy search is expand a node that you think is closest to a goal state, that you think. अभी तक अपन इसमें कोई मैथमेटिकल कंस्ट्रक्शंस नहीं ला रहे हैं. ओके. Heuristic estimate of distance to nearest goal for each state. This is what we have done, covered what is a heuristic. A common case is best first takes you straight to the wrong goal. जैसे अपन ने उसमें देखा, we reached to Bucharest but that was not the best goal. Worst case, like a badly guided DFS. So what are these two figures trying to illustrate? पहला वाला ये and second वाला ये. This is the Best case, you are directly taking me to the goal state, but this goal may be wrong. Wrong in what sense? It is not optimal, right? So it is not taking to you to a state which is not a goal state. It's a goal state but not optimal. And what is happening in this case? The worst case still goes like DFS. Okay. Now, so which one is this? Let me do it again. Greedy, start and directly taking me to, but this looks too good to actually happen in practice. In this case it was empty, so fine. Now let us talk about this one. How do we relate this with what we had seen previously? Previously क्या था? Which algorithm we used? Remember when everything was covered? UCS. And what was the property of UCS? Expand in all directions. Now in this case what are we doing? This is greedy. You are not expanding in all the directions. You are expanding in only the direction of the goal. So let's say it started in this direction, took this path but didn't work. So finally we are not exploring it. So we are not exploring what is not relevant to us. Okay. Now we come to one of the most important algorithms. It's almost everywhere there, right? We can think of Candy Crush as our state space problem. You start from a start state, there is a goal state, there are paths, multiple paths to reach to that goal state. But जो game design कर रहा है, that person, the team has to ensure that there is a path, right? You can't give me a task which cannot be completed in, let's say, 45 steps. And of course you are not going to do this thing manually. Ki if user explodes green, then do this. This is a hopeless case, right? So we start with A star now. A star is, so UCS was too slow expanding in all the directions. Greedy was too greedy. So you have to, maybe the other way around would make more sense, because this guy is going to get only slower. Alright, so ये important है. अभी 3 बजे क्लास थोड़ी है, 3 बजे भी क्लास थोड़ी है. So let's quickly do this. टॉय प्रॉब्लम अभी तक अपन ने ये नहीं देखी है. ओके, इट्स अ टॉय प्रॉब्लम, अभी तक अपन ने नहीं देखी है. फ्रॉम वॉट एवर यू सी हियर, टेल मी व्हाट इज द बेस्ट path to the goal. So as to A, then it makes no sense to go to E. So S A D G. Make sense? Chalo. So let's start. What are these H values? Heuristic. कहां से आया? In this case, somebody has given it to us. Okay. In real problems that you will be solving, you will have to figure out what should H be. But in this case, somebody has given me H. What is G? The cost that I was talking about without H. ये जो actual में move करने की cost है. Okay. Now, so uniform cost orders by path cost और backward cost GN, ये अपने UCS वाली cost है. ये अपने UCS वाली cost है. Fine. एंड ये अपने ह्यूरिस्टिक ग्रीडी. ओके, so we start S G0 H6 and you keep on doing this. हाँ जी, ये ना, ये सबसे इंपॉर्टेंट लाइन तो ये थी. नाउ टेल मी हाउ वुड यू प्रोसीड इन दिस केस. एक बार खुद से करके देखो इस पे फटाफट, आई मीन इस ट्री पे कर लो. सो हाउ, व्हाट इज योर स्ट्रेटेजी नाउ? इट इज नॉट UCS, इट इज नॉट ग्रीडी, इट इज नॉट BFS, नॉट DFS, नथिंग. व्हाट इज योर स्ट्रेटेजी? Expand in the increasing order of this sum. A star orders by the sum Fn equal to Gn plus Hn. If I do it Gn alone, what am I doing? If I am doing Hn alone, greedy. Add both and then proceed, that is your A star. So G0 H6, how do I get to know these values? लिखी हुई है वहां पे. Okay, so I have no choice. What is there in my fringe? S. Now from S I come to A. G equal to 1, H equal to 5. What do I do next? A is in my fringe. The moment I expand A, what comes to my fringe? B, D, E. What do I expand next? D, because 4 plus 2 is lesser than any of these guys, and then it takes me to G. Is that the right thing to do? Right? Okay. So I think that is it for today. This one? Small g is my cost that is given to me. UCS वाली जो cost है, that is small g. That is given in a problem. H is not given to you, but in this toy problem that is also given to us. You have to figure it out. H is in what is H in general we'll see later. है ना? But I have already given you hints कि it is in some sense simplification of a problem. वहां पे H करो, will come to those things. हाँ. Attendance? All right, we go.